Good morning. Welcome to section 7.2, Graph Exponential Decay Functions. This lesson is actually really similar to the previous lesson, and not much is going to change. The big difference that you're going to see here is now that your b value is not going to be greater than 1 as it was with exponential growth, but your b value is going to be between 0 and 1. So you have to think rational numbers, okay, but they have to be between 0 and 1. So the first example we're going to graph will be on the next page. We're going to have a b value of 1/2. A couple things just to note again. Your x-axis is still the horizontal asymptote. Your range is still going to be y is greater than 0. So even though this function is falling, okay, we're still, all our output values are above the x-axis. Okay, so that means your range is going to be y is greater than 0. The domain is still all real numbers. We can use any x value. And a great thing here is if we look at 0 and 1, 1 and b, those are 2 points that we can still use to plot this as we did in the previous example, in the previous section. So let's go ahead and look at this first one. Okay, in this case our b value is 1/2. Okay, so we can just identify that at first so we know. Now you only need a couple of points to plot. You know, if you plug anything to the 0 power is always 1, so that was our one hint on the points we can plot. And then the next one here is if you put 1 in, you actually can just plug b. So you get 1 and 1/2. Now it's best to use negative numbers here because for x, if you're going to add any more, because then you invert that actually. So if we plug in -2 for x, 1/2 to the -2 is the same thing as 2 squared. Okay, and if we want to write that, 1/2 to the -2 is the same thing as 2 squared if you simplify it. Okay, so now we can just plot our points. We know that the x-axis is our horizontal asymptote, so we have 0, 1, 1.5 right here, and -2 would be 4. If we plug -1 in, would just give us 2. So we're going to go ahead and try to sketch this function as best we can. We're above the axes. Okay, so that's our sketch. All real numbers is the domain, y is greater than 0 is the range. And so what we're going to do now is we're just going to graph one a little bit more challenging. Here our a value is -2 and our b value is 3/4. Okay, and now what's going to happen with this -a is that actually, remember, just like last time, we're going to flip over the axes. You can still plot a couple of important points here. Remember, for this type, if you have an a value other than 1, if x is 0, you just plot a. So 0, -2. Okay, and then if we plug in 1, it's just a times b. So -6 over 4, well, you can simplify this, 2. Okay, that's -1, so -3/2. So you have 0, -2, 1, -3/2. Okay, and the graph is actually going to look just like this. Follow that axis. Okay, now the domain is still all real numbers. So your domain, and they didn't ask us to do this, but it's always nice to just to write it. Our domain is all real numbers. Our range switches. It's not y is greater than 0. It is from 0. The range is from 0 to -infinity. Okay, that's how we graph that type of problem. Horizontal axis is still the asymptote. You can plug different values in. You could add more values just to get a more of a shape, but we only need 2 points here really to graph that function. Next, we're going to translate just like we did, and we're going to still plot the original function, and then we're going to perform a transformation. Okay, so we're going to plot this one first. 3 times 1/2 to the x. That's what we're going to plot first. So we can use 0, 3, right? Anything to the 0 power is 1, so this whole thing is 1, times 3 is 3, and then when you plug in 1, remember from the previous lessons, it's just a times b. So that's 3/2. And what we'll do here is we'll add another point in a minute. So we have 0, 3, and then we have 1 and 1.5. We could try 2, so if we plug 2 in, okay, you would have 3 times 1/2 to the second power, which is just 3 times a fourth. So our last ordered pair we'd plot would be 2, 3/4. So that gets a little tricky, so 0.75, so 2, maybe we're right here. Okay, so now we got to try to sketch this guy as best we can. Whoops. As best we can to follow the asymptote. We can make an arrow out of that. Okay, so it's not the smoothest graph, but you can see that if the a value is a positive, you should be above the axis, the x-axis. So positive output, positive y value, range is greater than or equal to greater than 0, excuse me, and domain is all real numbers for this function. But is that the correct function? No. What do we have to do? We have to move right and down 2, but this is a plus sign, so you got to be very careful. Because of this plus sign, it's not moving right, it's actually moving each point left 1, everything down 2. Remember, this guy is your new asymptote. So let's just go ahead and draw a line down here. Okay, -2. A different marker here. Then you're going to move all these points one left, excuse me, and down 2. One right, down 2. One right, and down 1, 2. And 3/4, one right, and down 2. Right about there, I guess. And the red graph is our correct graph. So our range here is the most important. You're actually at -2 to infinity because you're above that line. So this is the correct graph. This graph in black is just the y equals 3 to the 1/2 of x. Oops. Okay. So what we're going to do now is we're going to make another video because this one takes a little bit of time and I don't want to run too long with video. We have exponential decay models, very similar to exponential growth models, but our growth rate here is not 1 plus r, it's 1 minus r. So with these types of problems, you see it with, like cars, depreciation. Okay, over time your car just doesn't hold its value. So that's a really similar, that's a really good example to show this, not growth rate, but it's actually a decay rate. A is going to, again, be the initial amount. R is going to be the rate, and that's the percent decrease. How much are you losing? And T is still time. And we call 1 minus R is the decay factor. So in the next video, we're going to go ahead and look at that. Okay? I hope this video helps. And if you have any questions, let me know. Thanks, guys.